Hello, everyone. You are welcome once again to the lesson on indices and logarithms. Okay, in today's lesson, we'll be looking at how to solve log equations, basically. Log equations. However, the main objective, or the lesson objective for today will be by the end of the lesson, the student should be able to define log equations, and should be able to identify log equations. However, ultimately, once you are able to identify log equations, every equation, we are usually asked to solve. So you have to know how to solve such equations as well. Okay, so quickly, let's move on to how to identify log equations. And you get that from indirectly the definition that I've given here for log equations. So a log equation, or logarithmic equation is an equation with an expression that contains the log of a variable expression. With an expression that contains the log of a variable expression. So it means you should have a log expression that contains a variable in that equation. A log expression that contains a variable. Okay, so example, if you look at this, you know that anytime an equation is formed, we are looking at two expressions linked with equal to. Do you agree?
Yes, please.
So out of every equation, we can get expressions. Okay, so take note. So if I look at this, or if you look at this, you see that you have a log expression here. That log expression, you can see a variable with the log expression. Obviously, that is x. So it means this is an equation in x, only that to be more specific, it is log equation in x, not the usual equation. Is that clear?
Yes, sir.
Okay, and again, you can see a log expression here in this equation. Okay, and that log expression, you can see a variable in that log expression. So this also makes this a log equation because it contains a log expression containing a variable. Okay, and the same for the third example. Okay, and the fourth example. However, if you look at the first three examples, you will see that your variable x is appearing in the number that you are taking log of. Okay, you can see that this is where you have the number that you are taking log of x. The number that you are taking log of is 2x minus 1. That is where the variable is. The number that you are taking log of here, and this one too, the number that you are taking log of. This one contains two, variable log expressions. Okay, this one and this one. But the first two contains only one. If you come here, you can see that, if you look at this log expression here, it contains a variable, and the variable is appearing in the number that you are taking log of. However, with this one, the variable is appearing in the base. Can you see that? Okay, it is still a variable expression, containing log or log of a variable expression. So this is a log of a variable expression, log of a variable expression. So your variable can either be in the base or the number that you are taking log of, usually. However, the variable can also be the coefficient. Okay, take note, but usually you consider the variable as the base or the number that you are taking log of in the definition. But if it still has a variable attached to it as its coefficient, it is still a log of a variable expression. So please take note. All right. Okay, so now if you know how to identify log equation, let's see whether we can, based on the main definition, concept that I've given you. Let's see, check whether this is, a log equation. Is this a log equation? If yes, why? If no, why? I'm indirectly trying to see whether out of the definition, you'll be able to identify log equations. Because as one of the objectives, you should be able to do so. Then we'll know that that objective has been achieved. Anyone? Anyone? Is this okay, Akosia?
The multi is not a log equation because in the definition it says it contains the log of a variable expression. But then with the variable here, it doesn't contain a log. It's just on its own. So it's not a log equation.
Perfect. Okay, so your log expression here, you don't see any variable with it, be it the base, the number that you are taking log of, or the coefficient. Okay, so it means this ceases to be, okay, a log what equation. So take note. So if you're able to answer this, then I believe, okay, now you can identify, okay, log what equations. Okay, however, like I said, okay, if you are able to identify log equation, that is not it. You should be able to solve, okay, such equations as well. So let's go and look at how to solve log equations. Okay, so quickly, we move on to our next slide. So solving log equations. And here we have two methods. Okay, and each method I'll walk you through the steps. Okay, when I explain the steps, okay, we'll pick example. And usually in maybe the first two examples, I will use both methods, okay, and see whether we will land at the same results. And later I will advise you as to the nature of the question and the method that will be best suited. Is that clear? Okay, so quickly, let's look at the method one and the steps. So for method one, okay, the very first step is to isolate the non-log word terms, if necessary. Isolate the non-log word terms. So it could be non-log term or terms. That is one. Then two, express the log terms as a single log. And you can see if necessary, very soon you know why. Because certain questions will come and the first step has been taken care for you. Okay, so the second step, you can see the second steps too, you can see if necessary. So it's possible the first step has been taken care of, the second step has also been taken care of. Okay, that is the log expression on one side, or expression is written already as a single log. Remember where we came from. In our previous meeting, we looked at how to express log expressions as a single log. So we are going to apply that in solving, okay, log equations here. Then, okay, step three, we switch to exponential equation by using the fact that, so you have, okay, now have log, a single log here is equal to a non-log term. You can see, he said isolate. So your non-log term will be here, and your log terms, which will be here, you write it as a single log, and every single log expression will have this nature. Is that clear? So it means, in effect, after going through step one and step two, okay, this will be where you've got into. Okay, and the step three will mean we need to switch from log to exponential. We know how to solve exponential equation. I remember when you were being taught log, we moved from indices to log. And I told you that you can also go back. So if you know every log statement, you know its corresponding exponential statement. So the log statement here, if I want to move to exponential, you know it will be a, your base a to this power x should give you your b. And that is what we have here. So we'll make use of this fact or this concept to switch from log to what? Exponential. And now once you get an exponential equation, this is your comfort zone. So you solve that equation. And that equation can be linear, can be quadratic, cubic. Now that you've done polynomials, you can get cubic as well. Okay, and that will be the step 4. And step 5, okay, and you can see that it is in bold. Okay, step 5, test for the validity of your solution or solutions mentally. Mentally. You remember, okay, when we were doing SEDIC equation, remember that, okay, after getting your solutions or the value or values of what your variable, you have to test before you draw your conclusion. Do you remember?
Yes, please.
Okay, so in the same way, okay, for log equations too, you have to test. However, the difference here is that for the static equations, your testing you are supposed to show. You don't do it mentally. Okay, but for the log, you do your testing mentally and you draw your conclusion. Is that clear? Okay,
Yes.
so one may ask at this point, why is it that the normal equation, okay, if you solve, you don't test? Okay, the normal equation, if you solve automatically, okay, whatever that valued or values that you get must satisfy automatically. So whether you test or not, okay, they will all satisfy. And it means every normal equation will have no restriction. Okay, unless maybe there is a denominator, okay, your variable is in the denominator, you know that if the denominator contains a certain number, okay, it will be 0. So that you check, then you pick that one. But usually normal equations, there wouldn't be any restriction. However, the static equation, you know, okay, you have restriction. That's why you have to test, because if I have root of a, I know this will give me a real number only when a is greater than or equal to 0, correct? So it means it's not all a that can be taken. Okay, so that's why you have restriction. Anytime you have restriction, it means you have to always test. So in this case, there is restriction. Log 2, there is restriction. Okay, I believe you have some of, if not all of you have your calculators with you. Okay, so if you have your calculator with you, this is what I want you to do. Okay, find log of what? Okay, let's say common log of -10. So press log -10 and press equal to, and tell me what you will get or what you had.
Math error.
Math error. Okay, so and press log 0 and let's see what you will get.
Math error.
Math error. So it means your number that you are taking log of, okay, here, okay, your b must be greater than, okay, 0, strictly greater than 0. Okay, you cannot take 0. Do you agree? So it means your number that you are taking log of, if it contains a variable, the variable will be restricted. So you have to test and check which variable must not be permitted and which must be admitted. Okay, now let's look at the base. Okay, find log to the base -10 of 10, and let me see. Or any negative number. Your base is negative.
Math error.
Math error. Your base is 0. So log to the base 0 of maybe 10.
Math error.
Math error. So it means your a also must really be greater than 0. You get it? So that's why once there is a restriction, you have to test. You substitute and see whether when you substitute your x, okay, assuming maybe we solved an equation, maybe log x is equal to something, and we had x to be negative. If you substitute, you know, it will not be possible for you to get because you don't have log of negative. It means that x value must be discarded. Okay, Akosia?
That one is fine.
It's fine. Okay, all right.
Okay.
So that will be it for the method 1. Now let's go and look at the method 2, the steps that we need to adapt. Okay, for the method 1, remember we said we have to isolate the non-log, okay, term or terms. That's what we are supposed to do. Okay, and it's the same as, I can also, instead of saying isolate the non-log terms, I can also say isolate the log terms. When you isolate the log terms, then you see that the non-log term also will be isolated. Is my point well made? It's like Akosia and Princess being together, and I've been asked to isolate Akosia. Immediately I isolate Akosia, Princess is also isolated. Is that not it?
Yes, ma'am.
Okay, so it's the same way. So it doesn't really matter which one. However, here, okay, I am more interested in what you are isolating. The step 2. Sorry, the method 2. Okay, step 1, isolate a log term if necessary. So with this one, you always have to make sure that there is one log term standing alone. There is one log term standing alone. Okay, so on one side of the equal to, there should be only a log term. Okay, that's the step 1. Step 2, make sure, and you can see if necessary. So it means maybe in certain question, okay, you will see your one of the log terms already isolated. Okay, so it means that step is not necessary. It has already been catered for in the question. Then you move on to step 2. Make sure any non-log term is expressed in its corresponding log expression or log term. So with this one, it means basically, okay, you need to get all your terms to be log terms. So anytime you see any non-log term, you express it as what? As a log term. Okay, and very soon you know how to do that. Anyway, let me quickly chip that one in here. Maybe you can relate better here. Okay, so assuming I have 2, or even let me put it this way, assuming I have 1, I can always write 1 as a log term. And 1, I can write this as log, assuming my base is 2, I can write this as log to the base 2 of 2. It's the same as 1. Is that not it? So the 1 initially was not a log term. Now I have expressed it as a log term. Is that clear? Hello, are you with me? Okay.
Yes.
All right. So in the same way, if I have 2, the number 2 in the equation, and I need to change it towards a log term. Okay, usually your log equation will come, okay, your log terms will come with a base. So it's the base that will help you to, okay, attach or change your number that you have, the non-log term to a log term. So if I have 2, and in that log equation, my base is, let's say, 3. The base of the log is 3. Then I will just attach log to the base 3 of 3. And you can see that it's the same as 2. So I'll attach that. This one is the same as also attaching, okay, this to 1. 1 is here, but you don't write it. So if 2 is there, write the 2, then attach. So it's like 2 times this, which is, this is 1. So it's the same as 2. Is my point well made? So if I have x2 and x is not a log term, okay, obviously it's not a log term. If I want to make it a log term, and in that equation that I see x, which is a non-log term, okay, the base of the equation is maybe 10. Then it means I'm going to write log to the base 10 of 10 and attach it towards, okay, at the x, because I need to attach 1. So it's the base in the equation, the log base, that will help you to attach whatever that you have here. So your attachment should be the base that you have there, and your number that you are taking log of should also be the same as the base, so that it will be the same as 1. So you've not changed the value of the x, only that you are writing it in another form for, okay, a certain purpose. Is that clear? Is my point well made?
Yes, please.
Great. All right. So now then you move to, okay, the step 3. Express the log terms on the other side of the equation as a single log. So you can see that here too, we are making use of what the single log concept. So if you don't know how to express log expressions as a single log, okay, it means you wouldn't be able to solve log equation, because the first method involved that. Okay, needed that, and the second method too also needs that. So again, if necessary. So sometimes you see that already that side will be a single log. Okay, so it means this step will not be necessary. Now, okay, the 4th step. Okay, so it means with this one, on one side you have a single log there. The other side, initially it wasn't single log. So you will now change it to a single log. So it means this time around, on both sides you have single logs. Okay, terms there. So that's why we say make use of the concept of equality of logs. And the concept of equality of logs, okay, I introduced you to that in our previous lesson. Remember I said if I have log to the base a of b to be equal to log to the base c of d, okay, if this is equal to that, then A must be equal to C. Your basis must be the same. And what? The numbers that you are taking log of should also be the same. Is that clear? So B must be equal to D. All correct. We did that. Okay, so whenever it's the same concept that we are going to use here, your single log here will have a base. Your single log here will have the same base. So with this one, the bases will always be the same. Once the bases are the same, this will be equal when the numbers that we are taking log of is equal. So that's why we said we make use of the equality of log concept. And the concept is that if log to the base A of x is equal to log to the base A of y, then x must be equal to y. So you just equate. In certain books, you see taking anti-log. Okay, it's not necessary. Don't take the anti-log. Once the coefficients are the same, the bases are the same, just equate. That's all. And 5, when you equate, you are going to get an equation. Okay, so you have to solve that resultant equation in 4. So your resultant equation, if you solve, you will get either a value or 2 values. Sometimes we won't even get a value. Okay, not all equation can be solved anyway. If I get a quadratic equation, not all quadratic equation will give me real roots. Some will give me complex roots. Okay, however, usually when you solve, you get what? The root or the solution. So you solve the resultant equation, but remember again, with this one, the last step is very critical. Test for the validity of your solution or solutions mentally. Okay, so if you don't have any question, then we'll go and look at what our worked example, take each question, okay, or maybe the first 2 questions, subject each one through the steps that or the method that we have here, and see whether we'll end up getting the same result. Any questions? Hello, any questions? Okay, so if that's the case, then let's move on, okay, from this English to maths. Okay, so our first worked example, we are to solve the following equations. Okay, and once you see, if you look at critically based on the definition, okay, the A, okay, you will say that it's not a log what equation. Is that not it? It's
Yes.
not a log equation. But please take note. Okay, I'm going to make it blank or blanket. Let me put it this way. I'm making a blanket statement. Okay, now every equation that involves a log expression, okay, take that as what? Log equation, and you use the concept of log, okay, to solve. So every equation that you see a log term in it, whether the number that you are taking log of contains a variable or not, your base contains a variable or not, okay, take that to be a log equation. Is that clear? And use the technique of solving log equations to deal with it. Point well made. Okay, so now let's go and look at the solution. Okay, so when you read question, make it a point to underline the salient part. We are asked to solve the following equation. You can choose not to underline solve because every equation usually you have to solve. If you needed any other information, we'll tell you. That's why we would ask you to find the true set of the equation. So in this case, just solve. So you have to solve. So let's go and look at what the solution. And like I said, we are going to use, okay, the 2 methods. So quickly, let me look at what method 1. Okay, that's what I'm going to use to solve. So what am I giving? So question number, major question number is 1. Minor question number is A. And what are we giving? We are giving, okay, log to the base 4 of what? 1/4 is equal to x. Is that correct? Okay, now if you look at the first step of the first method, we said we are supposed to isolate our non-log terms. Is that clear? Term or terms. And you can see that in this equation, the only non-log term here is this, and it is isolated. Can you see that? It is not standing with the log term. So it means step 1 already catered for. So it's not necessary for you to do that. It has been done for you. Is that clear? Hello, please, can you hear me, my professors?
Yes, please.
Great, all right. Okay, so now let's see. Step 1 done. Step 2, what are we supposed to do? After taking this one, okay, then I log term to one side, isolating it. The second step is to write your log terms as a single log, am I right? Which will be on the other side. So here on the other side here, thankfully, we already have a single log. Can you see? So it means that step 2 already catered for in the question. So it is not necessary. It doesn't need any effort from you to do that. Okay, step 3, what are we supposed to do? We need to switch from a log to exponential. Is that not it? Okay, so on that note, we know that we are going to make use of that concept, that if you have log to the base a of b is equal to x, then your base a here to the power x should give you the number b. Okay, so that's what we are going to use. So this implies that, okay, my base here, which is 4, to this power should give me 1 over 4. So 4 to the power x should be equal to 1 over 4. That is how you switch from log to exponential. This is a base. This was a power. Okay, remember we said anytime you are dealing with log, you are looking for the number to which you are supposed to raise your base to get this number. Okay, so the number x here is what you are looking for. So this x should be equal to the number, okay, that you are supposed to raise the a to get the b. And I said that in the introduction of the log, okay, video. So don't let us go back. Okay, so at this point, exponential equation, and we are experts. So what do we do? 4 to the power x. Okay, this will be equal to 4 to the power negative 1. Is that clear? Hello, it's my point.
Yes, please.
Very good. So at this point, some of you maybe would want to change this one to 2 to whatever power. I've told you, first of all, check whether the base that you have here, the other one, you can write it at the same base. It's when you cannot write it at the same base that you try changing them to a common base. So now I'll write my x will be equal to negative 1. Do you agree? Okay, however, we said we have to test. Okay, but we test mentally. But my point is, anytime your variable is not appearing as a base, or even, okay, the number that you are taking log of, it's not that, okay, or what is containing your variable, okay, and it's any other thing, please take notes. Okay, it will always work. Your restriction will be on the base or the number that you are taking. So any other place that you see your variable, it means there is no restriction, so it will automatically work. Okay, so at this point, I can write my therefore here. So I'm done. All correct. And if you like, feed your calculator with this and see, your calculator will give you -1. So it means that's the value that you are supposed to get there. Any questions before we move on to the second method? Hello, any question? Okay, so if you don't have any question, then method 2, again, we have to extract. So what are we giving? We are giving log to the base 4 of 1 over 4 is equal to what? X. Perfect. Okay, now if you look at that one, okay, the method 2, we said first step, isolate the log term. Okay, isolate the log term. So there is a log term here. Is that clear? So isolate a log term, one of the log terms. So you have to isolate one. But here there is only one log term, which is already isolated. Am I right? So that's why you have the if necessary there. So it's not necessary for you to isolate. It has been isolated for you already. Okay. Then step 2 is to write, okay, all the non-log terms, okay, as log term or as a log term. And you can see a non-log term here. Is that clear? So it means step 2 is necessary here. So I'm going to write, this implies that, okay, log to the base 4 of 1 over 4, okay, will be equal to, if I want to write this as log, remember I told you, consider the base of your other side, the base of the log, okay, expression that you have there, and that will guide you to attach whatever. So this will be x times 1, and 1 will be the same as log to the base 4 of 4. Is that clear? Is my point well made? Or I should come again?
And Mr. Akno,
Yes, please.
please can you write it as log 4 to the base 4x?
Log 4 to the base
It has,
4x.
yes, or it has a different meaning.
No, you see, because you are going to use the concept of equality of sets, the bases must be the same. So that's why you go for the base here. So that this side too, the log expression here will have the same base.
Okay.
You get my point?
Mr. Akman, please, I'm saying, can you write the right-hand side as log 4 base 4x?
Are you okay? The way you are reading it, as if you are not a mathematician. Log to the base 4 of 4x. Is that what you are trying to say?
Yes, please.
No, it will not be 4x. Very soon you know what must be here proper. But if you understand what I have told you, that if you want to change it to, okay, a log term, just attach 1. And if you want to attach 1, it will be log, okay, to the base a of a. And how do you get your a? Your a will come from the base of the log term that you see in that equation. Is it clear now?
Yes, please.
Okay, so at this point, you know, we know that along the line, the steps, we will use the concept of equality of sets. And equality of set, we said the, what do you call it? The coefficient must be the same, the basis must be the same, so that we can equate the numbers. But the coefficient here is 1. What's the coefficient here? X. Is that clear? However, you can make the coefficient of this one 1. Okay, so how do we make it 1? By taking, you know, any coefficient, anything that is multiplying your log came as a power. You remember? So I will take this one up here. So in actual fact, it's supposed to be log to the base 4 of 4 to the power x, not 4x. Akosia, do you get it?
Yes, please.
Okay, and you know, if you bring the power down, you go back to this. Is that clear? So now that you've written it this way, bases are the same, coefficients are the same. So it means the numbers that you are taking log of must also be the same. So I'll write, that implies that, okay, 1 over 4 should be equal to 4 to the power x. Am I right? So it means using the second method. Okay, look at all that we have to do before getting to this stage, which was our first stage in the first method. Can you see? So you've now gotten here, and the continuation will basically be the same. Is my point well made? So this question, between method 1 and method 2, which one do you think is ideal? Okay, which one do you think is ideal? I'm waiting. So this will give us 4 to the power negative 1 is equal to 4 to the power x. Okay, which will give us, okay, x is equal to negative 1. So therefore, x is equal to negative 1. I said, yeah, you can conclude without testing because your x is not a base, it's not appearing in the number. So any other, you conclude straight away. Let me check. All right, okay. It was Bushra. Okay, so this will be it for the A. Okay, we are going to look at the B together. Okay, and that of the C. Okay, however, please take note, this is my humble advice. anytime, so this is the best way to determine which method will be best for you to use. Anytime the given equation contains a non-log term, use the first method. That would be the ideal method. Anytime all your terms in the equation are log terms, it is convenient and ideal for you to use the second method. Okay, so based on that, okay, the B, okay, which method do you think it would be best for us to use here? Based on what I just said. Or I should come again.
Yes, please.
I should come again.
Yes, please.
I said, okay, if in the given equation, not all your terms are log terms, use the first method. If in the given equation, so it means, okay, if that information that you are giving here, the condition is not satisfied, then you have to use the other method. And that condition will be, okay, the other method for you to use that would be all your terms are log terms. If all your terms are log terms, then you have to use the second method. But if at least one of the terms in the equation is not a log term, then use the first equation. And you can see that here, this is a term. It is not a log term. That's why when you use the first method, we did little or no work. Is my point well made? Hello, is my point well made now? So
Yes,
based on that, the B, okay, this is a log term, am I right? This is also a term, an unlog term. This is also a term, an unlog term. Okay, so this equation contains, okay, two non-log terms. And I've told you even one non-log term, okay, should tell you the method that you are supposed to use. How much more than one? So which method will be best here? One or two? Method one or two?
One.
Method one, very good. Okay, so that's what we are going to use. Okay, so now let's see how best we can use method, okay, one to solve that of B. And if need be, we'll look at method two too and see how best we can use that method in such a situation. Okay, so let's move on to the next one. So the next slide, we are looking at the solution to B. Okay, B, 1B, what are we giving? We are giving, okay, log to the base 4 of what 64 is equal to what 2 minus 3x. Is that clear? Okay, so like you said, we are going to use the first method. The first method, we have to isolate the non-log terms. And you can see that in this equation, the non-log terms are already isolated. They are on one side of the equal to sign. Is that clear? Okay, and the other side will contain non-log term or terms. Okay, if it contains terms, then write it as a single log. But here it contains only one, which is already a single log. So that step will not be necessary. Okay, then the next step is to switch from, okay, log to exponential. So that is what we are supposed to do here because we have a log statement here, not exponential. So we are going to switch. So if you switch, it will be 4 to the power this side, whatever that we have here should be equal to 64. So it's like 4 to the power 2 minus what? 3x is equal to what? 64. All correct. Please, are you following?
Yes, please.
Okay, very good. So at this point, you have exponential equation. You know, to solve exponential equation, okay, each side should have a base to a certain power, but the bases must be the same. So can we write 64 to contain 4 to a certain power? And the answer is yes. That will give us 4 cubed. Am I right? Okay, so the base is the same. We equate the exponents. So this implies that 2 minus 3x should be equal to 3. Okay, so now what do? We move this one to this side. So we are going to bring this one here. So we get 2 minus 3, which will give us -1. It's equal to what? 3x. All correct. You write it again before you divide. So 3x is equal to -1 over 3 over 3. Okay, then your x will be equal to -1 on 3. Okay, however, you can see that the x is not a base. It's not the number that you are taking the log of. Okay, so it means here when you test, it will work. Okay, always. So your x is not restricted. So I come and draw my conclusion with that x. All correct?
Yes, please.
Okay, very good. Any questions at this point? Okay, so now let's see if you can use the alternative method. It will be long anyway. Okay, the method 2 to deal with this. Okay, so let's see. We know that ideally it is method 1 that we are supposed to do. So let's explore a little and see what will come out of that. So assuming I'm looking at the alternative method, which obviously will be method 2. So that one too I need to extract. So what am I giving? Okay, I'm giving log to the base 4 of what? 64 is equal to what? 2 minus 3x. Okay, in that method, what is the first step? Isolate a log term. Is that not it? And already you can see that you have only one log term which has been isolated. Then after that, what do? Your other terms that you have there, if you see any non-log term, change it to a log term. And here I have 2 non-log terms. I hope you can see that 2 and 3x, these are all what? Non-log terms. So I'm going to change this one to a log term. And I know the base here, that will help me. So I'm going to write that one, whatever I have here, as, okay, let me see if I can write it here. Yeah, I can. I think it will go here. So this implies that I have log to the base 4 of 64 is equal to, writing this as a log, okay, term will be 2 times what? Log, you remember the base, it will be a of a. The a will come from the base of what you have here. So it will be 4 log to the base 4 of 4. Is my point well made? Then minus this one to 3x, then you attach the same thing, log to the base 4 of 4. All correct?
Yes.
Okay, and remember with this method, we are going to use the concept of equality of sets. Did I say said? Or equality of log. Okay, so at this point, what do? We are supposed to write, okay, the other side, okay, or one of the sides, okay, which is not a single log, as a single log. So if this one was a single log, then we'd have, okay, checked whether the coefficients are the same. If the coefficients are not the same, we'll move it up so that it will be 1. It will be the same. The basis will always be the same. Once, because the base that this base that you consider to form what you have here. So automatically they will all be the same. Then now, okay, the other side, we are going to write it as a single fraction. We are experts in single fraction situations. So I'm going to write, this implies that, okay, this side has a single fraction. Did I say a single fraction? A single log. Okay, 64. Log to the base 4 of 64 is equal to, now before I can write this as a single log, remember the coefficient should be 1 or -1. Is that clear? What we did, okay, now last meeting, okay, in the lesson 5. Okay, so now what do? We are going to write this one as log, okay, to the base 4. The 2 will come and give us 4 squared. Okay, then minus, okay, log to the base 4, then the 3x will now come up and give you 4 to the power 3x. Is my point well made?
Yes.
Okay, so now what do we have? Whatever that we have here, which is the log to the base 4 of 64, okay, will be equal to, writing this as a single log, remember, okay, we know this will give us 16, but when we are writing, we can write the 16 there. So I'll write my common log or my single log, which is log 4, log to the base 4. Then you know you have positive and negative. Once you have positive and negative, the bar should come. Okay, the numerator will be occupied by the coefficient, the one with the coefficient being +1. So the numerator here should be 4 squared. Okay, I could have written 16 there. Then the denominator here, will be 4, okay, to the power, okay, 3x. Is my point well made? Hello, is my point well made?
Yes.
Okay, so coefficient the same, basis the same. So it means the numbers that we are taking log of should also be the same. So I'm going to have, this implies that, okay, 64 is equal to 4 squared over 4 to the power 3x. And you know, exponential equation, 64 we know is 4 cubed. Okay, and that should be equal to, this is the same as 4 to the power 2 minus 3x. Is that clear? And you can see that at this
Yes.
point, we are at this stage. So look at all that we are supposed to do when you went the alternative route. All that we were supposed to do before getting to this point. Just with this one, just a step, 2 steps, you are there. Look at all that you were supposed to do. Okay, the first step, second step, third step, fourth step, fifth step before we got to that. So obviously, okay, you know that you now agree with me that this will not be the right way to go, the ideal way to go, but the first one. So that's why I said immediately you see an unlocked term there, please use the first method. So here you continue like the way we have done here, and you end up getting, okay, therefore, x is equal to minus 1 on 3. Is my point well made?
Yes, please.
Okay, all right. So it means when we set this question and we are providing constraints, we are providing space, we will use this one to provide a space, not this. Okay, take note. All right, so that will be it for B. Okay, we are going to look at the C and the D. Okay, and as for the E, once you see it in green, then it means you are likely to see it somewhere. Abi, you catch. Okay, all right, so now this is it. C, based on the advice, which method do you think would be ideal for us to use? Method 1 or 2? Hello, method 1 or 2?
Method 1.
Method 1, because you can see an unlocked term here. Okay, so let's extract, then go and apply or use the method 1 to solve that equation. So giving log to the base A, okay, of 25, okay, is equal to what? 2. Okay, so now what do you do? Okay, this time around, you know, a single log is equal to, so you switch straight away. You know that step 1, not necessary. Step 2, not necessary. Okay, step 3, we are going to, so now what do we have? You get a squared. This implies that a to this power, so a squared, is equal to the number here, which is 25. So we switch from log to exponential. Is that clear? Okay, so at this point, you are solving for a. So what do? You take the square roots of both sides. So square roots of a squared should be equal to square roots of this. But remember, I've told you, anytime you are taking the square roots, what question did I say you should ask yourself? Someone should make me proud. Hello? My professors, who is making me proud? Hello? Hey, are you there? What did I say? Anytime you are taking the square roots, change of subject, and you are taking the square root, what should you ask yourself?
Plus or minus.
Plus or minus. Okay, you ask yourself whether the quantity that you are looking for, okay, is really positive, it's really negative. If it's not really positive, you don't have enough information, be it direct or indirect, to say that it's really positive. You don't take only the positive root, which is the principal square root or the principal root. Then, if you don't have sufficient information, direct or indirect, for you to say that it's really negative, for you to take the negative square root, okay, you have to introduce plus or minus. However, here, we know that the A is a base. Is that not it? Okay, so once A is a base, okay, we know our A cannot be negative. It's really positive. Remember where we started. We said the restriction is that A must be greater than, it's really greater than 0. Your B must also be. So in this case, I will take only the positive square roots, having thought before writing. So it will be positive square root of 25. So in this case, you get A is equal to what? 5. Okay, and you go and check. A is positive. So if you substitute mentally, you know that the base can take a positive value. So I draw my conclusion. However, okay, if you introduce plus or minus, assuming, okay, you did this, and you said root of A squared is equal to plus or minus, you didn't ask yourself that vital question. You didn't get sufficient. You think you don't have sufficient information. So 25. So that will give you A to be equal to plus or minus 5. So A will be equal to 5 or minus 5. So it's now that you are going to test mentally. If A is equal to 5, yes, the base can be positive. What about A is equal to negative 5? The base cannot be negative. So it means you have to discard the negative and conclude with the positive. Therefore, A is equal to 5. So you draw the same conclusion if you think afterwards. Is that clear? Before you take the square root. So this one we taught before taking the square root. This one we taught after taking the square root. You get it? All right. Okay, so now that will be it for C. Okay, I'm not going to take you through the alternative method. Okay, or the method 2, because we know, okay, that is ideal. So always, I want that to be part of you as well. Anytime you look at the equation, you know the best method to go for. So it means, yeah, you are compelled to know both methods, because you know every situation and the method that will be convenient for us to use. So let's look at the D. Okay, and that will be it for, okay, D set of questions. So D, what are we giving? We've been giving log to the base 10 of what? 5x plus 6. Okay, is equal to 2 log to the base 10 of what? 5x minus 6. All correct. Okay, now, based on the advice, which method will it be convenient for us to use? Ideal, method 1 or method 2? Hello, method 1 or method 2? Hello, my professors, are you there? Method 1 or method 2?
Method 2.
Method 2, because all your terms are log terms. Okay, so we are going to use the method 2 as well. So the method 2, okay, we are going to use the concept of equality of sets. Equality of log, forgive me. Okay, so in this case, on each side of your log, you are supposed to, your equation, you are supposed to get a single log. So thankfully, this side has a single log. This side also has a single log. So if you go through the steps, you know, isolate one log term. One log term is isolated, whether this or this, it has been isolated. The next one is to change all the log terms to log terms. And here we don't have any non-log terms, so it's not necessary. Then after that, the other side, write it as a single log. Then you come and equate. So what do? I will now write, this implies that I cannot equate now. The bases are the same, but the coefficients are not the same. So I cannot equate these two numbers. Is that clear? Okay, so that will be equal to, now I'll have to bring this one up so that the coefficient will be the same and comfortably equate. So I'll get log to the base 10 of what? 5x minus 6. So what do we do here? Squared. Don't forget that. This will come up. So now bases are the same, coefficients are the same. So it means the numbers must also be the same. So I come and equate the numbers. So this implies that the numbers that I'm taking, the number that I'm taking log of here, 5x minus 6, should be equal to the number that I'm taking, okay, log there, which is 5x. So here is 5x plus 6. Okay. Okay, then 5x minus 6 all squared. All correct. Hello, are you with me?
Yes, please.
Okay.
Yes,
Now,
please.
at this point, assuming you've been given, so it means you now no longer, okay, you now don't have, okay, log in it. So it's like your normal equation, and you should be able to solve. So here, what do? We come and expand the side and combine like terms, if any. So now we are going to get 5x plus 6, okay, is equal to, this one squared will give us 5x all squared, okay, which will give us 25x squared. Is that clear? Then minus, we are using this concept, a minus b all squared is equal to, okay, a squared minus 2ab, then plus b squared. As for expanding a binomial, by now we should be experts. Binomial squared. Okay, so at this point, we need our middle term, which will be twice the product of this and this. The product of this and this will give us what? 30x. So twice that will give us 60x. Am I right? Then plus b squared. B is 6, so plus 36. All correct.
Yes, please.
Okay. If you can't do this mentally, it's better you come and write it as a rough work as what? 5x minus 6 multiplying 5x minus 6. That is the meaning. And woe unto anyone at this stage, if you come and write this one as 5x all squared minus 6 squared, you should know that anytime you have a binomial and you square, you get 3 terms. How come you have 2 terms? So something should click that there is something wrong. You don't write that for me. One of the exercises, I think some of you did that, the assignment. So at this point, we know that there's a quadratic equation in S squared. So we'll move all the terms here to this side. So in my mind, I'm moving all the terms here to this side, but I'm going to write, okay, what I have here first on this side. So that doesn't mean I'm moving to this side. So 25x squared. Okay, then I have minus 6x. This will also come. So minus 60x, forgive me, minus 5x will give us minus 65x. Is that clear? Then I will get 36 minus 6. So that will give me plus 30. Okay, remember it will be equal to, if you move this one to this side will be 0. So I'm writing it here. Is that clear? Okay, so please, at this point, what do you do? Or what would you do? How would you solve this equation based on a certain advice that you've been given? Let me see whether, okay, you've taken the advice, okay, in your stride. Hello, are you there? Okay, Akosia.
You have to reduce the equation.
Perfect. Okay. All right, perfect. So receive your clap. All right, so this is it. You have to reduce. And obviously you can see that, okay, you have a common numerical coefficient factor, a common numerical factor, I should say, and that will be 5. And because one side of the equation contains more than a term, we can, okay, choose not to show the division by 5. I mean, we can choose not to write it again and divide by 5. So what we will do is we'll divide mentally. So 25, okay, s squared divided by 5 will give us what? Will give us 5x squared. Am I right?
Yes.
Okay. Then minus 65 x divided by 5 will give us minus 13x. Am I right? Am I?
Minus 13x, yes.
Okay, x. Okay, then plus 30 over 5 will give us 6. Am I? And it's equal to, okay, 0 over 5, which is what? 0. Okay, so at this point, you can see, if you look at this equation and this equation, obviously, you know this is a PTR equation. And if you are supposed to solve this without reducing, you are going to multiply the 25 and the 30. So look at the huge number that you are going to get. You are going to look for the factors of this huge number, factor pair. That's when you multiply, you get that huge number. And when you add, you get minus 65. So once the number is huge, you are going to have a whole lot of factors to disturb you. You get my point. That's why it is advisable to reduce if you can be reduced before you, okay, solve. So at this point, we are going to multiply the 5 here and the 6, which now we have smaller numbers, so we can get the value mentally. So 5 times 6 will give us what? 30. So we are looking for factors of 30, which when we factor pair, multiply, we get 30, add, get minus 13. So it will be minus 10 and minus 3. Do you agree? So we'll split this one using the two factors. So 5x squared minus 10x, okay, minus 3x plus 6 is equal to 0. You group, but remember, don't use bracket to show your grouping. It is very risky. Okay, so now what do? We'll group the first two mentally and factorize. So 5x, okay, into x minus what? Minus 2. Okay, then here, last two factor, it gets minus 3 out. Okay, x, okay, minus 2 again is equal to 0. So you come and use the zero product rule. That means, no, not yet. We are not through with the factorization. So 5x minus 3, okay, into x minus what's 2 is equal to 0. So zero product will set each of the factors to 0. So 5x minus 3 is equal to 0. The connector is or, be careful. X minus 2 is equal to 0. Don't use comma, don't use n. I'm repeating for emphasis. So I'll come and do x here, solve for x. X will be equal to 2 here. Here it will involve a little more work. So 5x is equal to, you move this one here, 3. Okay, you write it again before you divide. Don't forget, this time round, it's just a term. So over 5 over 5. So your x here will be equal to 3 on 5. So how many x values can we see here? Have you gotten as the solution? We have 2. Is that not it? Hello, my professors. Are you with me? Okay, good. So once we have 2, okay, please, let's see whether we need to investigate or check the validity of these 2, okay, solutions. Okay, this time round, unfortunately, your variable is appearing in the number that you are taking log of, which is somehow restricted. In fact, it is restricted, and same here. So if you pick 3 on 5, come and substitute into the original equation and see whether this number that you are taking log of will not be negative after the substitution, or this number, any of the numbers here which will involve x, will not be negative. Immediately one of them is negative, don't take it. Okay, you can't conclude with. So if it's 3 on 5, I'm just substituting, doing that mentally. So it will be 5 into 3 on 5. The 5 will cancel. So I will get 3 here. So it will be 3 plus 9. So plus 6, which will give us 9. So this is positive. Okay, now let's come to this. We cannot use only this one. Let's come to this. It will be 5 into 3 on 5. The 5 will cancel. You get 3 here. So 3 minus 6 will give you minus 3. Am I right? So you have a negative here when you substitute. So it means this cannot be allowed. Let's go to this one too and see. If x is equal to 2, 5 times 2, 10, plus 6, 16 here, positive. If x is equal to 2, 5 times 2, 10 minus 6, 4, also positive. So it means here I can draw my conclusion with only, okay, the value of x to be 2. So therefore, x is equal to what? 2. Is my point well made?
Yes, please.
Okay, all right. Akosia.
So, please, with the first one, when you use 3 on 5, for the right-hand side, you had -3 in brackets. But then when you bring the exponent, aren't you going to have a
No,
positive number?
you don't bring the exponent. Treat it in its raw form. You
Yes,
get
please.
it? So it will be 2 log, okay, whatever that you have there. So once it's negative, forget about it. That's why I said put it in the original, not the transformed. Remember I said that. If the original had a squared, then maybe we'll allow, but the original they didn't have it as squared. It has that as 2 times, so you substitute directly. Is that clear?
Yes.
Okay, good. Okay, so now that will be it for D. The E will be yours. At this point, we are going for our water break. We'll come and continue, move on to the next set of questions. Okay, so welcome back from the water break. Now we are looking at our second, okay, worked example or worked example 2. Okay, and what are we supposed to do? We are supposed to find the true set of the following. So with this one, you know, as you read, you underline true set. Very critical. Okay, so meaning if your answer is not in the true set form, okay, you will not move to the next question. So quickly, let's go and look at the solution, okay, slide. Okay, so now this is what we have. Let's go and look at that of what? A. And all of them, now we know, okay, which method will be ideal by looking at the equation. So if you look at the first equation, which method will be ideal? Method 1 or method 2? The A.
Method 2.
Method 2, because all your terms are log terms. Very good. So we go to A. So 2, solution is what you write first. Question number, major question we have. Minor we also have. So giving, and what are we giving? Log. Okay, the base is 10, common log, but it's not written, so you also don't write it. Of 5x minus 4. Okay, is equal to, okay, log, common log of what? X plus 1, okay, plus common log of what? Of 4. Okay, so with this method, the second method, first step, isolate a log term. Is it necessary for us to do that, looking at the question? Hello, is it necessary? Remember we said if necessary. It's not necessary because you can see one of the log terms already isolated. You have a log term here. Okay, then the next step is to change all the non-log terms to log terms. But here, if necessary, it's not necessary because all your terms are log terms. Then after that, the other side that you have more than one log term, write it as a single log. So we are going to write this side as a single log because we want to use the equality of log. And equality of log, each side of the equal to must have a single log. So it's this side that must be worked on. The other side here is already a single log. So this implies, okay, log, okay, 5x minus 4, okay, will be equal to, if you come here, coefficient is 1, 1. Okay, the bases are the same, so you can write this as a single log straight away. Okay, and the coefficient plus 1 plus 1. So it means these two numbers that we are taking log of must multiply in the numerator. The denominator will be 1. So it means this will give us 4 into x, okay, plus 1. All correct. Hello, should I come again or my point is well made?
Please come again.
Okay, who said I should come again?
This is Princess.
Princess, okay. Princess, Assuming I give, as for this side, it's okay. Assuming I give you this one, okay, to take as a express as a single log. You know what we did last time? Check. The bases are the same. Coefficient should either be +1 or -1. Thankfully, coefficients here +1, +1. There's nothing to move up. So immediately you get that, then you know. You write your log, then you have to determine which of the terms, okay, will have the numbers multiplying the numerator and the denominator. So here, all the terms are positive. So it means you get the denominator to be 1. So only numerator. So this and this will multiply the number that you are taking log of here and the number here. So it's like this 1 times 4, which is the same as 4 times this. It's better you write the 4 first because that's a monomial followed by the bifactor. Is that clear?
Yes, please.
So we didn't do any magic. Okay. All right. So at this point, coefficient here 1, coefficient here 1, base here 10, but it's not there. Base here 10. So bases are the same, coefficients are the same. So it implies the number here should also be equal to the number here. All correct.
Yes, please.
So 5x minus 4 should be equal to what? 4. And like I said in books, you see antilog, taking antilog of both sides or take antilog of both sides. Please don't use that. Just equate. Once the coefficients are the same, the base use equality of sets. So that will give us equality of what? Log. X minus 4 is equal to, you come and expand this, 4x, okay, then plus 4. Okay, now you are solving for x. So you check whether if you move here, you get positive. You want to avoid negative, then you move. So here, if you move here, you get positive. So it will be 5x minus 4x. That will give us x. Then you have to move this one to the side. So it will be 4 plus 4. That will give us what? 8. Okay, but we go and check. We're going to substitute and see. Okay, this is where you have the x and see whether it will satisfy. This will be positive after substitution. This will be positive after substitution. So 8, you are going to get 5 times 8, which is what? 40, is that not it? Is it 40?
Yes.
Okay, then minus 4, which will give us what? 36, positive. If you come and substitute 8 here, it will be 8 plus 1, which is 9. Positive here, it doesn't involve. So it means all your log, okay, involving the x. If you substitute, you get positive. So it's satisfied. So you draw your conclusion. Here it is true set. So therefore, okay, x is such that x is equal to what? 8. All correct. Is my point well made? Okay, Akosia.
Like my please doesn't mean if you put if you substitute x or 8 in every part of the equation, you're going to get the same answer on both sides.
Yes.
Exactly the same.
Yes. You get the same result. Okay, if you like, let's investigate and see how. Pause, then we investigate with our calculator. Zoom. Okay, so we have what? The B. You are going to do B together. Okay, the rest, okay, you try on your own. You don't submit. This one, obviously, you know. Once it's in green, you know. All right. Okay, and I think this also. Another question would be your assignment. So I believe with the first two, you should be able to appreciate. Okay, so now let's see. Okay, which question number? We said we are going to look at that of B. Okay, so B. Okay, what are we giving? We are giving, okay, log to the base 10. Here, the base is written, so you have to write it. Of what? 8x minus 1. Okay, minus log to the base 10 of what? 2x plus 1. Okay, it's equal to log to the base 10 of what? X plus 2. All correct? Okay. All log terms. So which method? Once again, method 2, right?
Yes.
Okay, method 2, first step, isolate a log term. in your equation, do you see a log term already isolated? Do you see a log term already isolated? Hello, can you hear me?
Yes, please.
Okay, so yes. Okay, which is this one, already isolated. So it is this side that we are going to write as a single log so that we can use the equality of log. Okay, once again, for you to use the equality of log, both sides of your equal to sign, you should have a single log. This side satisfies that, but this does not. So we are going to work on this. If you look at this critically, okay, let's see whether directly we can write it as a single log. And if you can do that, then it means the coefficient of all your log terms here, either +1 or -1. Coefficient of this log term +1, -1 for this one. So it means we can write this side as a single log straight away once the bases are the same. So this implies that your log of your same base, the base that you have there, which is 10, okay, once you have positive and negative, the bar should come. Okay, separating your numerator, denominator. Your numerator will be taken by, okay, the number that you are taking log of the positive coefficient. So that will give me 8x minus 1. It's not necessary for me to put it in bracket. And the denominator will be taken by this because the coefficient is negative. So 2x plus 1. And that should be equal to log to the base 10 of what? X plus 2. All correct. Hello, is my point well made? My professors, are you there? Is my point well made?
Yes.
Great, all right. So now what do we have? We have bases the same, coefficient the same. And the purpose was to use the equality of what? Of log. So we can use now. So it means this implies that this side, the number that we are taking log of, which is 8x minus 1 all over 2x plus 1, should be equal to the number that we are taking log of on this side, which is x plus what? Y. Oh, x plus 2. Okay, it's fatigue setting in. All right, x plus 2. Okay, so that's what you have. So at this point, it's like you've been given this equation to solve. Okay, you don't need my input match. Okay, you should be able to solve that. So we are going to solve it anyway. So I'm going to continue, okay, here. Okay, so assuming the next thing that we are supposed to do is to cross multiply, is that not it? I think there's a space here that can take the cross multiplication. So I'll write this implies that I can ignore. So I cross multiply. I'm going to get, okay, s plus 2 multiplying this. It's a binomial. So I'll write 8x minus 1 is equal to x plus 2 in brackets multiplying what? 2x plus 1. Is that clear? So indirectly, I'm going to get 8x, okay, minus 1, okay, is equal to, if I expand this, I'm going to get 2s squared, okay, plus what? X, then plus 4x, then plus 2. Okay, obviously we have a quadratic equation at hand. So indirectly, I am going to, the s squared term here is positive. So I have to move these two terms to the side. So in my mind, I'm moving to the side, but I'm writing whatever I need to write here. Okay, first. So 2x squared. Then I know this and this will give me 5x. This will come. So it will be 5x minus 8x. And that will give us minus 3x. Okay, and this is 2. This will come here and add. So it will be 2 plus what? Plus 1. And that will give us what? 3. Okay, and that is equal to what? You moved everything here. So this side will be 0. That's what I've written here. Okay, otherwise, okay, you can write a 0 here, then move. So you get 0 is rather equal to this. It's the same thing. Is my point well made? Hello? Is my point well made?
Yes, please.
Okay, so now let's see what is going to happen here. Okay, we are going to solve this equation. Okay, 2s squared minus 3s plus 6. Okay, let's see whether we can solve it by factorization. Can you get any factor pair? 2 times 3 is 6. Factor pair of 6, that when you add, you get minus 3. Multiply, you get 6. Any factor pair? Hello, my professors. Any factor pair? Okay, so like you said, you won't get, you won't get what? Okay, any factor pair of 6. That's when you add, you get minus 3. Okay, your b squared minus 4ac will not be a perfect square. So that should tell you that, okay, you cannot solve by factorization. Okay, or b1, once you do your test, b squared minus 4ac, you realize that it will give you negative. And once it is negative, it means you have no solution. If it's not a perfect square and it's positive, it means it has a solution, only that you cannot solve by factorization, but you have to use quadratic formula or the completing of squares. Okay, but preferably you use the quadratic formula when the factorization method fails. As for the completing of squares, unless you are restricted, don't use it. Okay, now that will be it for the solution to that of what? Of the B. Okay, the C and the D, you will try. Okay, but you don't submit the E, you know. So quickly, let's go and look at, okay, our next. This one will be your assignment. Okay, and it's supposed to be a class assignment, so I'll send it to you later. But let's continue to, okay, this question. Okay, so now we are going to look at, you remember when we did the exponential equation, forgive me. When we did the exponential equation, okay, we ended up looking at exponential equation leading to simultaneous equations. In the same way, we can have log equations leading to a simultaneous equation. And for the exponential equation, we said, if we are supposed to solve simultaneously, then it means one of the equations should be an exponential equation at least. So both equations can be exponential as well. The same thing here. Okay, with this one, at least one of the equations should be a log equation. Okay, so the first one satisfies that. One equation is log. The second one, both equations are log. Okay, so let's see how best we can deal with it. If you're able to deal with these two, then your assignment, you should be able to deal with it. So quickly, let's go and look at the solution to that of the A. You are supposed to find the true set, so you underline true set. Oops, please, this reminds me, I have to go back. You didn't draw my attention. It wasn't intentional. The other one that we concluded, we had a wrong conclusion. The question they didn't ask us to solve. Please take note. Okay, let me clear it. You didn't draw my attention to that. Okay, so once you were not asked to find a solution, you were asked to find a true set. So you have to draw your conclusion appropriately. So you write, your answer must be in the set 4. Therefore, an empty set. That's a true set. Is that clear? Hello, is my point well made? Very good. So let me, okay, move on to the next one. So take note of that. Okay, so now to the solution, okay, to A. Okay, so solution A, minor question number. What are we giving? Okay, we've been given the first one is 2y, okay, is equal to 9x minus 1. Immediately write your first equation. Remember, what do? You label it. And if you have space, you continue. Otherwise, you come down. Log, okay, to the base 10 of y, okay, is equal to 2 log to the base 10 of x, then plus 1. Remember, the plus 1 is not in brackets, so the log to the base 10 that is only affecting the x, not the plus 1, x plus 1. So take note. So this becomes your equation 2. Obviously, equation 1 is in the form that you want. By equation 2, no. So we have to take equation 2 and work on it. And this equation 2 that we have here, you can see that we are going to switch to exponential. And it will be better that way, or form an equation. But in working with this, you use the same, guideline as to the determination of the method to use in extracting your equation, moving from log to your normal equation to solve. And you can see one of the terms here is a non-log term. So it means that method 1 will be ideal. So method 1, what do we do? Okay, we have to isolate the non-log term. The non-log term here is with the log term. So I have to move this one to the side. All right, from, equation 2, comma, I'm going to work on equation 2. So log to the base 10 of y minus 2 log to the base 10 of what? X, is equal to what? 1. Okay, that's not all. You have to write this as a single log before we switch to exponential. So we are going to get, this implies that, log to the base 10 of y. We can't switch straight away because the coefficient here is 1, but it's not minus 1. Okay, so minus, you bring this one up. So that will give you log to the base 10 of x squared, and is equal to what? 1. My professors, are you following? Are you making sense in what I'm writing and saying at the same time? Okay, all right. So now the person who usually will respond in real time, is not around. Okay, so now what do we have? Oops, let me go back. Okay, so we can now write this as a single log. So we get log to the base 10. Now you have a term to be positive, negative, so bar will come. Y will occupy the numerator, and S squared will occupy the denominator. And that will be equal to what? 1. At this point, we switch from, log to exponential. So I'm going to get y over x squared is equal to 10 to the power 1. Is my point well made? Hello, is my point well made?
Yes, please.
Okay, so 10 to the power 1 we know is the same as 10. So it's like, now we cross multiply. So we get y to be equal to 10x squared. Is that clear? Remember, I have told you before you label your equation should not involve fraction. It shouldn't involve brackets. If it can be reduced, you reduce. So in this case, I will call this equation 2, or it's what? 2a. Okay, so now I can substitute 2a into what? Into 1. So I will go and write equation 2a into equation 1, comma. So now what will happen? Okay, wherever I see y here, it is what? 10x squared. So I will get 2 into 10, x squared, will be equal to 9x minus 1. So I'm going to get 20, x squared minus, I'll bring this one here, 9x, then plus 1, is equal to 0. Is my point well made? Okay, hello, is my point well made? I skipped the step, which you can equally skip. It won't be costly. So, but if you don't understand, I'm going to clear that one. Then, write the one that I skipped before I come to this one so that you can follow. Okay, especially those who couldn't come. Okay, so this will be equal to 9x, minus 1. So now what do we have? We have 20x squared. You move this one to the side, minus 9x. Move this one plus 1 is equal to 0. Remember, to solve quadratic equation, you have to move everything to one side. This equation cannot be reduced, unfortunately. Okay, so we are supposed to multiply 20 and 1. So we get 20 for the factor pair of 20, that when you add, you will get minus 9. You multiply, you get 20. I'm waiting for the factor pair.
Please.
Okay, So the factor pair will be -4, -5. So I'm going to write this one as, so I will use that the two factors to split this one. We are going to get 20, okay, x squared minus what? Okay, 5x minus 4x, okay, plus 1 is equal to what? 0. So what do we get? Group the first two and factorize. 5 out, okay, x also out. So I'll end up getting 4x, okay, then minus 1. Okay, then this one too, minus 1 will come out. Okay, then you get 4x minus 1. So it's equal to 0. Your complete factorization will now give us 5x minus 1 in one bracket, then 4x minus 1 in another bracket is equal to what? 0. So now set each of the factors to 0 and solve. Okay, it's equal to 0, or okay, 4x minus 1 is equal to 0. So you come and solve for x here. 1, write it again before you divide, over 5 over 5. So x will be equal to 1 over 5 here. Let's come to the x here. Okay, so 4x is equal to 1. Okay, 4x is equal to 1 again over 4 over 4. So you get x is equal to 1 over 4. So we have two values for x. So it means that you are likely to get two values for what? For y. So we are going to use each x to get what? The corresponding y. Okay, so now this is what we are going to write. If x is equal to, okay, 1 over 5. Okay, what are we going to get? Y will be equal to 10 into 1 over 5 squared. Are you with me? So this implies that your y will be equal to 10. We deal with the power first. Don't come and cancel. So it will give us 1 over 25. Okay, it's now that we can cancel because the exponent here is 1. So we will get y to be equal to 2 on 5.
Yes.
Okay, very good. So that is the value of y if x is equal to 1 over 5. Now we are going to look at the value of y if x is equal to 1 over 4. So we'll move on to the next slide. So if x, okay, is equal to 1 over 4, okay, y will be equal to 10 into 1 over 4, okay, all squared. So this implies that y will be equal to 10, deal with the power first, so it will be 1 on 16. Okay, and this 2 can be reduced. So y will give us what? Okay, 5 over what? 8. Am I right?
Yes, please.
Okay, so now we are going to investigate and see these values. Okay, especially let's see the log. Okay, so let's go back. Okay, so our log is this. So let's come concentrate on the log. Okay, none of your numbers there is negative. So it means, okay, the possibility of all your values here satisfying will be very high if you substitute, obviously, into this. So this x and this x, it can take, okay, the place of the x here. This y and the other y can take the place of y here because it doesn't go outside the allowed, okay, range. Y must be greater than, really greater than 0. So let's move on to this. So we draw our conclusion. See how the conclusion will be drawn. Here we have two values each. So it's going to give us, okay, therefore, who can help? X, comma y is such that x is equal to, what's the first x value? 1 on 5. Look at how we are going to draw our conclusion. Very critical. X is equal to 1 on what? On 5. Okay, and its corresponding y value. Y is equal to, okay, what did y give us in that situation? Y gave us 2 on 5. Okay. So y is equal to 2 on 5. Or, okay, x is equal to its second value, which is what? 1 on 4. And, oops, and, okay, your y, corresponding y is what? 5 on 8. Then you close it. All correct. So state the x and the corresponding y together. X and so don't come and write, therefore x is equal to 1 over 5, or, okay, the other value, which is what? 1 over 4. And y is equal to 2 on 5, okay, or 5 on 8. Okay, state the x and the corresponding y together. X and the corresponding y. That's how conveniently we conclude. Is that clear? Okay, so that will be it for A. Now let's go and have a look at what? That of the B. Okay. If you don't have any questions, then I'll move on. Yes, please. Any
Please,
question?
can you to the last slide?
No,
The
because
previous
of time. Okay, let's continue. Okay, I'll give you time to catch up.
yes.
Okay, all right. Okay, so now, do you write or you capture?
Please, I write, but
Okay, so it's better you capture for us to move faster. Okay, and cover more. Anyway, I'll go back with you, cause don't worry. So B, what are we giving? We are giving, okay, log to the base 10 of x, okay, plus log to the base 10 of y, okay, is equal to 4. That's your first equation. You label it as equation 1. And your second equation is also a log equation. Log to the base 10 of x, okay, plus 2 log to the base 10 of y, okay, is equal to 3. So this becomes your equation 2. So with this one, we have to transform, okay, both equations, unlike the first one that we transformed only one. So you come to from equation 1, comma, okay, we are switching from this to exponential, and you have one of the terms, okay, to be non-log. So it means the first method will be best. Okay, we can write this straight away as a single log because base is the same, coefficient plus 1 plus 1. So you write log, common log, or log to the base 10 of what? Okay, now the denominator will be 1. So this x and y will multiply, okay, in the numerator, and that should be equal to what? 4. So at this point, this implies, okay, that we switch to exponential. So we are going to get, okay, xy is equal to 10 to the power 4. Do you agree? Or 10 to the power 4 is equal to xy? Are you with me? Okay, so at this point, you can conclude with a 10 to the power 4. Okay, I mean, leave it at this point. So let's continue and label this as equation 1. Meaning you can choose not to write the 4, then the zeros. I mean, 1 0, then 4 zeros will come. So, okay, we leave it this way. So that will give us, okay, 1a. Okay, then we go and take 2. So from 2, from equation 2, what do we have? We have this. This is your equation 2. Okay, also you have 1 and log term. So method 1 will be best. However, this one, you can't write it directly as a single log. We have to move this one up. So that will give us log, okay, x to the base 10 of x. Okay, then plus log to the base 10 of what? Y. Then you square it, the 2 will come up. It's equal to 3. So at this point, we can write what we have there as a single, okay, log. So we are going to get, this implies that what we have here, log to the base 10 of this and this will also multiply. So x, y squared will be equal to what? Okay, 3. So you switch to exponential. So x, y squared will be equal to 10, okay, cube. Is my point well made? So this then becomes equation, okay, 2a as well. So we are going to solve 2a and 1a simultaneously. Is that clear? Okay, I know some of you would want to make S the subject. Okay, in one of the equation, then substitute, or Y the subject and substitute. But I am smarter, and equally you can be smart. Okay, so this is it. I know that what I have here, xy squared, is the same as xy times y. Am I right? Because I know the xy value, I can substitute. So I know this is the same as x, y times y is equal to what? 10 cubed. By xy, you know is what? Is 10 to the power 4. So I can say that this implies that 10 to the power 4, okay, y is equal to 10 cubed. So I can make y the subject here. So I'm going to write it again and divide. So I will get 10 to the power 4 y is equal to 10 cubed over 10 to the power 4 over 10 to the power 4. So in effect, we are going to get y to be equal to 10 to the power negative 1, which is equal to 1 over 10. Is that clear? Or you can get the 1 over 10 here straight away. You can move from here to here. Nothing is okay wrong with that. Is that clear? Hello, is my point well made? Okay, now you know why, so you can go and find our x. Okay, so only one y value, so likely you get one s value. So I will call this one maybe, okay, equation 3. And go and write equation 3 into any useful equation. So let's see the two equation, which one is prettier? I will go for, I'm looking for y. Oh, sorry, x. So I can substitute here or here, but this will be better. Okay, I don't see any square here, so that my work will be easy. So into equation 1a, comma. Don't let this take one line, like I always say. So what do we have? Okay, you get x times y. Y you know is 1 over 10. Okay, it's equal to 10 to the power 4. So now what do? You multiply through by what? By 10. Okay, let me see whether I'll have a solution slide. Oops. So it means I have to pause, then do the needful. Okay, let me continue here, assuming this is my next page. Okay, so I'm going to get, let me write here, then I'll go and continue there. So this will give me x over 10. So I will cross multiply. So I will get x is equal to 10, okay, to the power 4 times 10. So that will give me 10 to the power 5. Is that clear? Okay, so now you are asked to find the true set. So you go and draw your conclusion. Therefore, okay, x comma y is such that x is equal to 10 to the power 5, comma or and, okay, y is equal to 1 over 10. Okay, you close it. You close your curly brackets. Is that clear? Hello? Are we fine? Hello, are we fine?
Yes, please.
Okay, so here the import is, okay, take all your log equations to your normal equation, and it will always be exponential equation. That will take you to the normal equation. Then after that, you solve the normal equation simultaneously. That's all. Okay, but remember, you can see that here, I didn't go and check the substitution because I realized, or I didn't do the substitution mentally, because I realized that, okay, all my values there are positive. And whatever I have here, okay, the x and y are alone. So no quantity is attaching it for it to affect my positive to give me a negative result. So it will always be positive, always positive, positive, positive. So any positive number that I substitute there will still remain positive. So you equally have to do the test. So please take note, okay, of that. Okay, so this is going to be, okay, your assignment, your second assignment. Okay, I will put that on the platform, okay, very soon. Your first one is there, your second one. Your first one, the deadline likely to be, okay, this evening. Okay, then the second one, or I'll give you the two together and give you the same deadline. Okay. All right, any question before I finally bring the curtains down? Any question? Just on time. Any questions? Okay, so if not, then we thank God for. Okay, any questions? Kirsten, please mute. Okay, all right. So if you don't have any questions, then I'm bringing the curtains down. We thank God for a wonderful meeting and a successful one for that matter. God bless us all.